Professor Puri Thirathunthorn. Professor Puri will present her paper on Thailand. The titles Thailand's energy efficiency policy and socio-economic factors, impact analysis and evaluation. So the main idea of this paper is to examine and analyze how the Thai state's energy policy affect the household behaviors in energy consumption and usage. It is that all the main question of the paper is that what is the relationship between energy policy and household consumption behavior, household energy consumption behavior in Thailand. So for the today seminar will be conducted in English because Professor Puri want the want this seminar want this seminar to be accessible to the foreign audience. So I will give the seminar to Professor Puri. Thank you very much for Professor Puri for today's seminar and interesting paper. Please.
Thank you, Ajahn Trin, for introducing me and open this seminar session. First of all, I would like to thank Faculty of Economics for a grant for the personal development in presenting this paper at the 7th International Conference on Public Policy in Chiang Mai. So that's why I will use the same slide that I presented in Chiang Mai last week. As Dr. Trin already mentioned about the topics of this seminar, I would like to thank my co-author, Dr. Montian Satimanon, to help me and co-author with me on this paper and make this impact analysis and evaluation more econometrics and more quantitative. Thailand has implemented energy efficiency policy for decades, and we have mandatory and voluntary measures, rule and regulation. We focus on energy-intensive industrial building and transport sectors, and also even so, there is the paradox of declining energy intensity versus the increasing per capita energy and electricity consumption. So it reflects the interplay between economic growth, energy efficiency, and consumption patterns. That's why it's interest like generate our curiosity to conduct this study. And why the industrial building and transport sector have been central to the energy efficiency policy for decades. We found that policy and measures to promote energy saving in household sector have been limited. Before we start our study, we have done quite a large literature review on energy efficiency policy effectiveness and also the same topic, energy efficiency policy effectiveness in Thailand. And what we found is that most of the work have been conducted at the sectoral or industrial level, like textile and cement industry, building sector, factory. There is one study regarding the residential sector that is conducted by foreign in 2010. So we think that it has been a long while since then till now. So we have like generate our question regarding this energy efficiency policy effectiveness, and particularly in the household sector. And then we take a look at the literatures on household energy consumption and socio-economic determinants, how and why, and whether socio-economic characteristics have determined the pattern of energy consumption at the household level. And we found that there is the study regarding this issue in Thailand, but it covered a period like 2000 up to 2010 by Supasa, which is a long time, but it's a long time study. So we searched more and found that there is some study using the survey method with only the residential sample group in Bangkok, like Iem Trakul and Jiramit and Lim Mi Chok Chai. So we think that there is a research gap still available to do the study. Given the structural changes in Thai household energy consumption patterns that follow the COVID-19 pandemic, there is definitely the research gap into this. And the research indicates the significant changes in household energy consumption behavior during the pandemic period compared to the pre-pandemic years. And however, a systematic analysis of these changes across different socioeconomic groups remains limited. So we think that understand this pattern is crucial for designing the resilient energy policy. And a notable methodological gap in this study, in the previous study, showed that most existing studies rely on the basic descriptive analysis without exploring the heterogeneous effects across different socioeconomic groups in Thailand. So to fill the gap, this study filled the gap of research on the interactive impact of socioeconomic determinants and effectiveness of energy efficiency policy on household energy consumption in Thailand. While most existing study on household energy consumption in Thailand utilize outdated data or limited temporal coverage, this study addressed the temporal gap by utilizing the most recent Thailand Socio-economic Survey data spanning the period of 2018 to 2021. So it can provide a contemporary insight into the household energy consumption pattern. Time frame that encompasses both pre-COVID baseline condition and pandemic affected periods, allowing for analysis of how major economic shock impact household energy consumption behavior across different socioeconomic groups. And this study aimed to fill the methodological gap by employing the pool cross-sectional regression analysis for analyzing household energy consumption. This method can capture both cross-sectional heterogeneity and temporal dynamics. So in conclusion, our study, the objective of our study is to evaluate an impact of socioeconomic factors and effectiveness of energy efficiency policy on household energy consumption in Thailand. As we mentioned that we use the socio-economic survey. The data from this survey is collected and conducted by the National Statistical Office of Thailand. So this survey represents one of the most comprehensive household level data set available in Thailand, employing a stratified three-stage sampling design. Provinces are selected as a primary sampling units, followed by the district and villages as a secondary units, with a systematic random sampling of households within each selected village. So we have the representativeness from both urban and rural households across Thailand, 77 provinces in 5 regional areas, which are Bangkok Central, Northern, Northeastern, and Southern regions. The sample comprises 185K household years observation across 4 survey waves. In each wave, there is the balanced representation of approximately 45 to 46K households per year. The socio-economic survey provides detailed information on household demographic, education level for all households member, asset ownership across 23 categories of durable and appliances, wealthy characteristic, access to infrastructure services, expenditure patterns, housing characteristic, and energy consumption behavior. So with that set of data, we have construct and measure our dependent variables. In this study, we conduct two models. The first one is two dependent variables. The first model is household energy consumption model, and the second one is the household energy consumption per capita. When we construct the household level energy consumption, we combine the expenditure of 7 distinct energy categories, which are electricity, cooking gas, natural gas, kerosene, charcoal, firewood, and other fuel, with the expenditure value deflated to 2018 constant prices using the consumer price index. So we can have the real total household energy expenditure. Then we divided by household size, so we can get the household energy consumption per capita. Regarding the explanatory variables with the same set of data, we have construct 5 categories of explanatory variables, which are socioeconomic variables, household demographic controls, geographic variables, energy access variables, and energy efficiency policy effectiveness variables. Just to quickly explain how we construct and what have been included in each category. Our socioeconomic variable measures are education index and asset index. This aims to capture the complementary dimension of household, human, and physical capital that fundamentally shape energy consumption pattern in Thailand development context. The education index, which is normalized household education level scale from 0 to 1. It reflects accumulated human capital to formal schooling, vocational training, and literacy achievement operating to multiple channels, including income enhancement, technological knowledge, and institutional access, which collectively determine household energy management capability. The asset index encompasses durable goods ownership, and this index is derived from the principal component analysis of durable goods ownership, including refrigerators, air conditioners, electric stove, and the total appliances counts. So this proxy can provide a well proxy. It can capture the household economic status independently of the current expenditure flow. Regarding the household demographic controls, in this study, we include household composition, which are household size, to capture the potential economy of scale in energy consumption, dependency ratio, that measuring the proportion of dependent members, including children under 15 and elderly over 60, relative to working age adults, and there is the age structure as a control as well. Regarding the head characteristic of each household, we use age, gender, and marital status to characterize whether, as the head of the household, how they're going to make the decision regarding the energy consumption. Geographic variables distinguish urban versus rural residents, and also we have the regional fig effect that represent the regional location for Thailand 5 major regions. For energy access variable, the modern energy access variables represent a composite measure of access to modern cooking and electricity. So it can encompass not only the simple grid connectivity, but also the quality, reliability, and adequacy of energy services available to households. From a capability approach perspective, this modern energy access measure can help to measure whether household can utilize energy services for essential activities such as education, healthcare, and productive work, rather than simply having the formal connection that may be unreliable and inadequate. The total appliances variables count household ownership of high energy saving device, including of radios, televisions, fan, mobile chargers, and small kitchen appliances. This can represent the accessible entry points into the modern energy services without creating the significant affordability burden, and this measure provide insight into the household energy management capability and consumption pattern. So it developed the better energy budgeting skills, energy saving awareness, and technology optimization behavior that may reduce overall energy intensity despite the higher absolute consumption. So this variable can serve as an indicator of energy efficiency policy to reduce the household energy efficiency gap to the standard and labeling program for the electric appliances. And this effective energy saving standard and labeling programs contribute to alleviate the problem of asymmetric information and bounded rationality to use the high energy saving appliances. So with all these variables that we have, dependent and explanatory variables, we employ the pool cross-sectional analysis and separate them into the basic energy consumption models and per capita household energy consumption models. So for the basic energy consumption models, we have include explanatory variables, which are the education and asset ownership, and the urban or rural area is residents of the sample is also the important determinants of the basic energy consumption models. And we also include the years effect. So this variable will represent the years fig effect. And this one is the regional fig effects. Whereas in the per capita household model, we focus on the per capita energy consumption in each household to understand the pattern of household energy efficiency. So we include the modern energy access variable and the total high energy saving appliances ownership, the two key variables here. And also we detail more on the demographic composition, including the number of children and number of elderly to account for the factors affecting the per capita energy requirement and consumption efficiency. The use of I already mentioned about the use of the total appliance as a proxy of the energy efficiency policy effectiveness. So the year's effect and the regional effect is still in the per capita household energy consumption model. Before we generate our result, I just want to show the overview of the characteristic of Thai's household energy consumption patterns and socio-economic conditions by using the socio-economic data. On average, what we found is that the monthly energy expenditure is around 774 baht, which is around 23.83 US dollar. And this with the substantial, very high standard deviation. So it reflects the substantial variation across household. Per capita energy consumption average is 316 baht or 9.73 US dollar monthly. And again, that is quite high standard deviation. And this suggests that the higher income household consume disproportionately more energy. The socioeconomic profile indicates the significant heterogeneity in the sample. Education index mean is 0.316, suggests that the average household education level correspond to the lower secondary completion, and there is a room for improvement because min and max is 0 and 1. Asset index, it is the standardized asset index, which the mean is 0 and the standard deviation is 1. And it confirmed the successful normalization, while the range from minus 2.8 to 3.01 indicates a substantial wealth inequality across households. Demographic characteristic shows that Thai's household have average 2.79 members. This consistent with the Thailand's demographic transition toward the smaller family sizes. The dependency ratio of 0.605 indicates that each working age individual support approximately 0.6 dependence on average. But somehow the high standard deviation and the maximum value of 7 reveal considerable variation in the household age structure. The household head by age is on average 55.4 years old, reflecting Thailand's aging population, which is expanding from 11 to 99 years old in each household. And regarding the head of the family, and which is female, we found that we found that the mean is around 0.412. So most of the head of the household is male. And the number of children that age below 15, okay, there is quite a considerable number of children under age of 15. And in some family, the maximum number can go up to 8. So again, it reflects the variation of the household character, elderly person as well. And when we consider the geographic variables, we found that 57.9 households reside in urban area, which is slightly higher than the Thailand's national average, whereas 75.4% of households can access to modern energy services. And it indicates that nearly 1/4 of households still rely on the traditional energy sources, predominantly in rural area. And on average, each household owns 3.78 for energy-saving appliances. But again, the standard deviation is high, and the maximum value of this number can be up to 8. So it reveals the variation in the ownership of the appliances. Then we come up with the result. Firstly is on our baseline regression model, and this is the result, but I will discuss on the result rather than point out what number is this in this table. Then what we found is that the education effect is very strong. Like the increase in household education can increase the energy expenditure. So moving from no education to complete education associated with 51.1% increase in energy consumption. So it revealed that there is a substantial rebound effect, which is likely come up because the educated household have a higher income, enabling a greater energy consumption and better knowledge of the energy efficient technology and change in lifestyle. The asset wealth effect confirmed the strong relationship between household wealth and energy consumption, and this finding has a critical implication for Thailand's development trajectory. As the household accumulate assets through economic growth, energy demand will continue rising unless being offset by the efficiency improvement or behavioral changes. The result of the study shows that the household size elasticity of 0.496 indicates significant economy of scale in energy consumption. So it reflects the share consumption of energy services such as lighting, cooling, and appliances among household members. And the urban household apparently consume 9.1% more than rural household. This premium reflects the advantages of the urban energy infrastructure, different lifestyle pattern, and access to modern energy services. But when we look at the regional fig effect, we found the geographic or regional disparity. Relative to Bangkok, all other regions show substantially lower energy consumption. Lower around at 12 up to 38%, and that 38% belongs to the north, which means that that region consumes 38% lower energy than Bangkok. So these massive regional differences reflect Thailand's highly centralized development pattern, with Bangkok and its immediate vicinity having a superior energy infrastructure, maybe higher income and greater access to modern energy services. And the large gap belongs to the north and the northeast regions. And that aligns with the Thailand historical development pattern, where this area have remained more agricultural and less industrialized than the Bangkok metropolitan region that relies on the service sector. And what we found is that the year effects reveal important temporal dynamics in Thailand's energy consumption. Energy expenditure remains stable between 2018 and 19, but increased significantly during the COVID-19 period, 5.97% in 2020 and 6.21% in 2021 relative to 2018. This increase slightly reflects the pandemic-induced changes in household energy use patterns, including increased home-based activities, remote work, and outdoor consumption behavior. Then we move from the baseline model to the per capita analysis to review important behavioral and structural pattern. As I already mentioned that we add more the demographic variables and also the energy access and energy efficiency policy effectiveness variables. So the result regarding the human capital and energy demand, we found that there is the persistent positive relationship across specification, both baseline and per capita analysis. So it confirmed that the education can operate through multiple channels beyond the income enhancement, and that will have an impact on the energy consumption. And asset wealth, in this analysis, it showed that the asset can alter household energy consumption pattern to multiple channels. And this finding suggests that Thailand's asset accumulation process will generate the significant pressure on energy demand through the rebound effect, unless, again, accompanied by the efficiency enhancement, technological advancement, or behavioral intervention. The demographic composition, this per capita analysis showed that the dependency ratio coefficient of 0.13 indicates that higher proportion of dependents increase the per capita consumption. And the working age adults consume significantly more energy per capita than children or household or the older people in each household. The female-headed household showed 3% higher per capita energy consumption, potentially reflecting the different energy use pattern or bargaining power within the household. But this demographic pattern suggests that Thailand's ongoing demographic transition towards smaller families and population aging will have complex effects on the aggregate energy demand that depend critically on how the per capita consumption evolve across age groups. Relative to the other regions, the per capita analysis still revealed that Bangkok's higher energy consumption persists. And the persistence of these regional gaps in per capita terms suggests that they reflect the fundamental differences in energy access, infrastructure quality, and economic opportunity in each region. Regarding the energy efficiency policy effectiveness, what we found is that each additional appliances reduce per capita energy consumption by 47%. So this result support the effectiveness of the energy saving standard and labeling program under the Thailand energy efficiency policy. So household with more appliances use more efficient technology and have an energy conscious purchase behavior. With the per capita analysis, we found that there is the absence of significant years effect in per capita consumption. This result contrasts sharply with the total energy baseline consumption model, suggesting that the COVID-19 impact operated primarily through household composition and size changes rather than the fundamental shift in individual energy use pattern. So with all the results, we can come up with some policy implication that Thailand should strengthen and expand its energy efficiency standard and labeling program, as this represents the accessible entry points for households to reduce per capita energy consumption. Policy instruments should include enhanced appliance labeling requirements, financial incentive for the adoption of efficient appliances, such as rebate program or tax credit, and public awareness campaign that educate consumer about the long-term cost saving associated with energy efficient appliances. And the energy efficiency policy should be spatially differentiated with more aggressive energy efficiency standards and support program in urban area and Bangkok, while rural and peripheral regions require infrastructure investments and targeted efficiency programs that account for their lower baseline consumption and different energy access constraints. Thank you.
Thank you, Ajahn Puri, for insightful information. Now we have around 20 minutes for Q&A session. If you had any question, please raise your hand and ask Professor Puri for your questions. Thank you very much. Okay. Okay, no question now. Okay, อาจารย์ภายพล
Just one comment. Can you hear me?
Yeah.
Can you hear me?
Yes, I can hear you, อาจารย์ภายพล
Okay, all right. Just well, thank you, Ajahn Puri, for your presentation. I have one comment. That one dimension of the household energy consumption has to do with the type of resident, the type of residence of households, particularly in cities like Bangkok. A number of households live in condominium, high-rise buildings. And this can have some effect on the energy consumption of these households, because as we all know that in condominium units, you are not allowed to use cooking gas in the kitchen. So that really is a bias against the use of LPG. Most cooking is done by using electricity. So there's a bias in the consumption of electricity in this condominium household. I wonder whether Ajahn Puri take this particular characteristic into account in your study.
First of all, thank you very much for your comment. I have to admit that, first of all, this data is survey and conducted by the National Statistical Office of Thailand. So because we use their data, and I agree with you that the specific characteristic of Bangkok residents may be different and should take like deeper insight into their characteristic of their residents. But according to the socio-economic survey data, they don't have this much in detail. As you can see that they collect the data around 45 to 46K per year in 77 provinces across Thailand. So Bangkok, the Bangkok sample is not that big, or maybe it's just only a portion of the overall. So, but I think that is a very good comment. Like if you want to do the particular region or the behavior of the urban area, Bangkok should be the very good representative. Thank you.
Okay, thank you.
Thank you. And I feel Professor Negara, please comment or raise your question.
Okay, thank you, Puri, for your presentation and for the invitation to join this seminar. I have, I think, two questions. I think the finding in your estimation shows that education is very important, right? In influencing the consumption, energy consumption. So I'm wondering whether this education is actually just a proxy of income level, the household well-being, but not really the knowledge of the individual. So maybe you can highlight like whether there's a specific education given in school that teach students about how to conserve energy, how to choose a more efficient kind of energy products. Yeah. So if there's such thing in the education system in Thailand, probably there's actually a real impact from educating the public. So I'm just wondering whether this is really about the impact of education to how consumer behave or behavior, consumption on their energy, or it is just a proxy of their income level. Yeah. So the second question, I think you also try to compare between pre-COVID and during COVID time, right? The consumption of energy between the two periods. So it seems like the estimate for COVID is not significant. I'm not sure whether it is true or not, like whether the consumption, energy consumption during COVID is not really changed much. So if that's really the case, what happened? Maybe you have some insight why this can happen, and then should we consider thing will change after post-COVID, like consumption of energy will go back to maybe a higher level or remain stable. Again, there are many factors as well that influencing this, but yeah, I'm just wondering about the impact of COVID. Thank you, Puri.
Okay, thank you very much, Wake, for attending my seminar today. First of all, the question, your question regarding the education level, that one is we don't aim to use it as a proxy for income level, but to use it to demonstrate the character of the household human capital, that with their education level through the formal schooling, vocational training, and literacy achievement, and etc., that can determine the household energy management capability. So it is not related to the income level at all. But thank you for your question. And the next question regarding the COVID-19, because we run two models. The first one is the energy consumption models. That one, the COVID-19 parameter is really significant and highly significant. So it means, but the per capita model is not. So what we found is that probably COVID-19 pandemic can change the behavior of the whole household, but not a person in each household. Okay, so we still insist that with the COVID-19 pandemic, that really affect the behavior of the household energy consumption. Thank you, Wage.
อาจารย์ภูริ there are question for คุณพัชพงษ์ in the chat question he have three question yes
Okay. Thank you, Kun Pasapong. Where are you now? Okay, you are here. Okay, thank you for attending this seminar again. I thank you, everyone. And the energy in this study, yes, it is considered only electricity. The key, not only electricity, but an energy that consumed in each household. But it doesn't include the energy used in transport sector, which means that like the socio-economic survey, when they survey and collect the data, transport would be the transport expenditure. So it includes like oil, gas, whatsoever that you use in your vehicles. And it can be like passenger cars or motorcycles or whatsoever. So the energy here will include everything, but not the energy used in transport sector, because we cannot separate the transport expenditure into the energy expenditure in transport. Okay, and for the second question regarding the rebound effect, we don't consider the installation of solar rooftop. As I already mentioned that we relies on the we relies on the data on the socio-economic survey. So that doesn't include the installed solar rooftop. So when I talk about the rebound effect here, it is the rebound effect of the energy efficiency. This notion saying that why when we use the energy efficiency policy in order for the people or even the every sectors in the economy to reduce energy consumption and have more energy saving, but apparently the more they use policy, the more people consume energy. So that is the rebound effect in the way that when you decide you have more education, or maybe you have change your behavior or lifestyle in order to reduce energy consumption for each appliances, and that appliances is already highly energy efficient. It turned out that you use more numbers of appliances. So even if right now we have for example, highly efficient air condition, refrigerator, and etc. But at the end, the total energy consumption is higher. So what happened? This is called the rebound effect, because the once that we can save on something, we decide to use more appliance on the other things. So this is what they call the rebound effect on the energy efficiency studies. Thank you ค่ะ คุณภาสพงศ์
ครับอาจารย์ภูรี can I ask you a question about okay it might be not fair for you because it should not be the data but I wonder if because nowadays Thailand because now there is an increasing number of EV in Thailand and do you have some data about the household with EV or without EV with EV or without EV in energy consumption because I think most household that own EV they also use energy consumption to charge the EV. Thank you very much.
Thank you for your question. I think that EV and AI is the center of interest right now. Like people talk about it, that it will increase our energy consumption after all. But I have to say it again that in this study, we use the socio-economic survey data. So we cannot like generate we don't have the specific data on the EV in each household by the time that they collect the data. But somehow I think that National Statistical Office of Thailand may consider, but I already answered your question that I don't think that they collect the data. But as a matter of fact, IEA just launched the report probably 2 weeks ago. That actually not AI or EV that have consumed energy most in the world. Right now, the most consumed appliances that we have in the world is air conditioner. Number one is air conditioner, not EV or AI. That's why the policy is more at the household level, that how to, apart from making energy affordable, but to save more, because they are like a runner-up to become the number one of energy consumption.
Okay ครับ Okay, I think we have a time for one present. We have around 5 minutes left. No? Or if the participant don't have that, if the participants don't have any question, I will ask Dr. Puri to close to put some statement to close this seminar.
Thank you everyone for coming to my seminar and have participated and engaged in our discussion. So thank you very much. Have a good day.
Okay, thank you อาจารย์ภูรี and participant ครับ See you next time for the next paper of อาจารย์ภูรี I don't know when but sooner or later meet again. Thank you อาจารย์ภูรี and participant ครับ See you next time for the next paper of อาจารย์ภูรี I don't know when but สวัสดีครับโอเคครับ